Hello students, now we are doing numericals of electric current through conductors. We are having page number 220, page number 220 and sum number 4. First sum we are having there. What is the resistance of one of the rails of a railway track? Railway track they are 20 km long at 20 degrees Celsius. Temperature is given. The cross section area of rail is given 25 centimeters square and the rail is made up of steel. So it is made up of steel having resistivity at 20, same temperature. So you are independent of the temperature at 20 degrees Celsius. This is the resistivity which is given. So for resistance, which formula we are going to use? Okay, it is a very simple sum we are having for the solution. We are having the relation between resistance and resistivity. What we are knowing the formula for resistance is we are using. So given, if we can write, it is your given, that is an answer we are having. We can write as given, we can write length is L is 20 kilometers, we can write in meters, that is 20 into 10 raised to 3 meters, and then talk about area is area of the rail 25 centimeters square, we can write, convert that into meter, 25 into, if we are writing into meter, because all SI unit we need, it is 10 raised to minus 2 meter the whole square. That will give you 25 into 10 raised to minus 4 meter square, and resistivity is given by rho, that is given 6 into 10 raised to minus 8, that is ohm into meter. Already it is in SI unit. So they are all in SI unit. We have converted that. Now we are going to use to find. What you are going to find is your resistance, that is R, capital R, resistance of the rail. What is the solution? So what is the formula for that resistance? R is rho L by A. Already we have seen the relation between resistance and resistivity, length and area of cross section of the conductor. So that is the conductor, that is a rail that is made up of steel. So resistivity of the steel is given to you. So here just let us put a value. R is rho. What rho we are having is 6 into 10 raised to minus 8 into length of this. Length is 20 into 10 raised to 3 divided by area of cross section, that is 25 into 10 raised to minus 4. Students, if you are going to solve this, okay, you solve this, it is a very easy solution. Just cancel out some terms and the final answer you will get approximately 0.48 ohms. Just check out the answer. Okay, so by solving this you will get the resistance of the rail is 0.48 ohms. Sum number 2. Okay, a battery after a long use has an EMF 24 volts and internal resistance 380 ohms. Calculate the maximum current drawn from the battery. Can this battery drive starting motor of a car? Okay, so what is the formula for current? Maximum current formula already we have seen. Current flowing through external resistance, that is I maximum we are knowing, that depends upon current rating, depends upon I max, that is E by R, not R plus R, it is E by R. That is the formula we are going to use for maximum current drawn from the battery when it is not connected to external resistance. So R is the internal resistance and E is the EMF. So directly very easy sum. What is your E is 24 volts and internal resistance of the battery itself is 380. And if we are going to calculate this, okay, please calculate this. We will get the answer as 0.063 ampere, 3 something, that is approximately 0.063 ampere. Can this battery drive starting motor of a car? Can this battery drive starting motor of a car? No. You cannot use this current maximum to drive the starting motor of a car because it's required somewhere 6 ampere to 10 amperes. So it is very less, we are getting 0.063 ampere. So we cannot use this to drive starting motor of the car. Sum number 3, we are having a battery of EMF 12 volts. 12 volts battery, internal resistance of that battery is 3 ohms, is connected to a resistor. So a resistor is there. If the current in the circuit is 0.5 ampere, we know the current flows to the external resistance plus battery EMF. Entire current is 0.5 ampere and resistance we have to find, and calculate terminal voltage of the battery when the circuit is closed. So when the circuit is closed, when the battery is on, we are going to find terminal potential voltage across here 3 ohms across the resistance. So first is we are going to find resistance, and then we are going to find voltage across this resistance. Internal resistance is given to you of the battery. Okay, so what formula we can use here? Okay, so what is given to you is running battery ka EMF. Battery is going to supply voltage is 12 volts, and internal resistance of that battery, of this battery cell, is 3 ohms. Okay, and current flowing through that. So they have given what is the current flowing through that battery. Entire circuit current is 0.1 ampere, because current will flow from this EMF also, and it is going to flow from the external resistance also. What you have to find is, that is, number one is resistance of the resistor, and you are having terminal potential difference, that is V, we are going to find. So when you know the formula, current I is E upon R plus R, or moreover we can write total EMF provided is divided into 2 parts, that is IR across resistance and its own internal resistance, that is R. Already we are knowing about this. So current is given, internal resistance is given, we have to find this. Why we are using this? Because I we can take common, here I we can take common, and R plus R, okay, but no need of, we can take common as E is current flowing is same, but we want to find R plus R. So here what we can do is, instead of this we can directly write IR is E minus IR, and moreover resistance is E minus IR. On this current we can do this way. So IR is E minus IR, R is E minus IR upon I, and then find out what is E. E is your 12 volt minus current is, we are having current 0.5 into your internal resistance is 3 ohms, divided by, we are having current flowing is 0.5 here. So we will calculate this. 12 minus 5 is 15 is 1.5 upon 0.5. See what answer you will get here. So it will be 12.12 minus 1.5. Somewhere solve this, see how much answer you will get. So how much we will get here? 12.5. That is, here it is 10.5. Yes. So basically you are getting 10.5. Okay, so this 0.5, it is somewhere 105.5. This 5 2s are 10. 1 to 5, it is R is 21 ohms, and then the second thing is we are finding potential drop across that resistance is given by, second is your V is IR, current flowing is 0.5 ampere, okay, and resistance we got as 21. So what form answer we will get here is 21 half, that is 10.5 volts. So voltage potential drop across this resistor R is 10.5 volts. Fourth, we are having the magnitude of current density in copper wire. Copper wire, we are having current density, it is current per unit area. Is 500 ampere per centimeter square, it is given centimeter square. If number of free electrons per centimeter cube of copper is, so this is number of free electrons per centimeter cube, we are going to convert into meter. 8.47 into 10 is 22. Calculate the drift velocity of the electron. So when we are going to apply electric field, what will be the drift velocity of the electrons with copper wire? Charge of 1 electron is given. Now here we will just write the given data for this. Okay, what is we are having given is your current density, G we write basically divided by J, current per unit area, that is 500 ampere per centimeter square. Let us convert that into meter square. We are having 500 ampere that is ampere upon centimeter square, we can write 1 into 10 raised to minus 2 or 10 raised to minus 2 meter the whole square. So 10 raised to minus 2 meter, because 1 centimeter is 10 raised to minus 2 meter, and the whole square, which will give you as 500 into 10 raised to plus 4 ampere per meter square. Minus 4 plus 4 is will go up, and here we are having number of electrons again, that is small n, number of electrons. Small n is capital N upon volume. Total number of electrons upon volume is per centimeter cube. So that is small n, is denoted by small n is 8.47. 10 raised to 22 we are having per centimeter cube. So here again what we are going to do is we have to write 8.47 10 raised to 22, this is per centimeter cube, is again upon 10 raised to minus 2 the whole cube. So that becomes 10 raised to minus 6 will go up, it is going to become 8.47 10 raised to 28 per meter cube. We are converting into per meter cube. Minus 6 plus 6, that becomes plus 1. Moreover, we are going to find charge of an electron is given to you. To find drift velocity, that is VD. Solution, what is the formula for drift velocity? Or we write J is NEBT. We should know this formula. We have proved this formula. Current density terms of drift velocity. So VD is current density divided by number of electrons into charge of 1 electron. This density is 500 into 10 raised to 4 divided by number of electrons is 8.47 into 10 raised to 28 into 1.6 into 10 raised to minus 19 coulomb charge of an electron. Please solve this, students. By log and anti-log you can get the answer. So for drift velocity we are going to get 3.69 10 raised to minus 4. Unit is meter per second, the unit of drift velocity. The unit of drift velocity is meter per second. So due to electric field, the drift velocity is less, 3.69 into 10 raised to minus 4 meter per second. Sum number 5, we are having 3 resistance 10, 20 and 30 ohms are connected in series combination. Okay. Find equivalent resistance of series combination. So it is very easy. Equivalent combination of series resistor combination, when series combination is connected to 12 volt, by neglecting value of interactions obtain potential difference across each resistance. So it is very easy sum. You should know what basically it is. It is something like this. We are having 10 ohms, we are having 20 ohms, we are having 30 ohms, and they are connected to your voltage power supply, that is 12 volts battery, and then easily you can do 12 volts. This is my 10, this is my 20, and this is my 30 ohms resistance. Okay, neglecting internal resistance. Now what is the finding equivalent? So what is the equivalent resistance formula? We know RS is 10 R1 plus R2. Directly in series we write R1 plus R2 plus R3. So we get it as 10 plus 20 plus 30, 40, 50, that is 60 ohms. During resistance series, equivalent resistance series is we are having 60 ohms. And then what is the current flowing through this? Because we need to find the second one also, drop across each resistance. So current flowing will be same, but potential drop will be divided into 3 parts. So but to find the current flowing through this. So what is current? We are having E upon R plus R. So but interactions is neglected. We know that since R is 0, we write current is E by R as equivalent. So that is equivalent resistance I is 12 volt battery, and R equivalent is we got 60. So 12 by 60 is what will be the current flowing through this? Let us calculate what is the current flowing through this. So let it be, we will keep as it is. Current flowing is same, that is 12 by 1 upon 5. Or we can write it as 1 upon 5. So current is 1 upon 5 ampere. Or 0.25 to 0.2 ampere also you can write. So what we need is basically we need Second part, potential drop across these resistance, that is V1 is I1 R1, that is I1 is 1 upon 5 into 10, that will give you 2 volts across V1, then V2 is I2 R2, drop across this is current I R1, current being same, current I R2, that is 1 upon 5 into 20, that is 4 volts, and then again V3 is IR3 because current flowing is same, so again 1 upon 5 is we are having 30, that is 6 volts. So when we add 6 plus 4, that is 10 plus 2, so 12 volts value, we are getting that. Problem number 6. Here we are going to see parallel combination. In problem number 5 we have seen series combination. So similar way, but here it is we are having parallel combination. So here if we are going to see the diagram, we are having two resistances which are connected in parallel. Yes. One we can just name it as 1 kilo ohm, another we can name it as 2 kilo ohms. They are connected in parallel and then they are connected to a cell. We are having a battery which is your 9 volt supply. Current will be dividing into I1 current and I2 current. We know in parallel current is divided, but potential drop across these two resistances will be same. Like in series we are having current is same and potential drops are different. In parallel we are having current will be flowing through the resistance are different, but potential drop is same. First we are going to see find equivalent resistance of parallel combination. For this we are doing the first part, that is directly I am not writing given now, we are just solving this first one. Equivalent resistance of parallel combination. What is the formula for two resistance which are in parallel? We are having 1 upon R is 1 upon R1 plus 1 upon R2. Moreover, if I want to convert this kilo ohms, we can convert this kilo ohms into ohms. Okay. So if we want, we can add R1 is 1 kilo ohms, is that means 10 raised to 3 ohms, 1000 ohms, and R2 is we are having 2 kilo ohms is same thing, we can add 2 into 10 raised to 3 ohms when we write in ohms. Here we are having equivalent resistance in parallel, that is, or moreover we can just, our equivalent is we can just write R1 into R2 upon R1 plus R2 if we are going to solve this. R1 plus R2 and then reciprocal of this we will get. So what we are getting is R equivalent of this is R1 into R2. What is R1? It is 10 to 3 into R2 is 2 into 10 raised to 3 divided by 10 raised to 3 plus 2 into 10 raised to 3. If we are going to use this formula, R1 into R2 upon R1 plus R2. So what we are getting is 2 into 10 raised to 6 and 2 plus, it is basically it is 10, 2 into 10 raised to 3 into 1 into 10 raised to 3. 2 plus 1 is, you get 3 into 10 raised to 3. So we are getting 2 by 3, 10 raised to 3, that is ohms. You can also write 2 by 3 is 0.666, 0.66 and 10 raised to 3. Okay, 3 6 is 18 and 3 6 is 18, that is ultimately we are getting, it is nothing, 0.66 kilo ohms. You can write directly resistance equivalent. Okay, but for current directly we can use to find by neglecting internal resistance, calculate current through each resistor. So what is the formula for current? Current we can directly write I1 current flowing is V, because potential drop is same, so V by R1 separately we can use this. Current is I1 is potential drop is same, so V upon R1 we are not writing V1, so V by R. So how much is V? We are getting 9 volts, and resistance R1 we are adding in R1 is 10 to 3. So basically we can write I is V is IR, so I1 we are writing current flowing through the resistance R1 is we are adding V by R1, that is 9 upon 10 raised to 3, that is in ohms. So here you are getting 9 into 10 raised to minus 3, that is in ampere. And similarly we can get current flowing through I2 is V upon R2. Okay, so we write it as 9 upon R2 is how much? 2 into 10 raised to 3 ohms. Okay, and then we are getting here as 9 upon 2, that is 4.5 into 10 raised to minus 3 ampere. So this is what we are getting current flowing through resistances R1 and R2. Sum number 7, we are having based on temperature coefficient of resistance. This sum, a silver wire has resistance of 4.2 ohms at T1 degree Celsius, at 27 degrees Celsius, and resistance becomes 5.4 ohms at 100 degrees Celsius. So there is a rise in temperature, resistance increases. Determine the temperature coefficient of resistance. So we have to find alpha here, factor. See, already students, we are knowing, let us write the given data. We are having your resistance, suppose we are adding R1 is 4.2 ohms, and here at T1 it is 27 degrees Celsius, and the resistance becomes 5.4 ohms at the temperature when it is heated 100 degrees Celsius. Okay, silver wire, when it is heated to 100 degrees Celsius, the resistance increases, you know that. And here you have to find alpha for the silver, because temperature coefficient of resistance is different for different materials. So we are going to find alpha for this material. Now we know the formula for alpha. Definition is change in the resistance upon original resistance. So basic formula is change in the resistance upon original resistance per degree rise in temperature. That is delta T. We use T1, T2, delta T is this way. But since it is already the temperature here is 27 degrees Celsius, so instead of R1 is R0, we are writing here R2 minus R1 becomes R1, and then there is a delta T also rise in temperature, so that becomes alpha is R2 is 5.4 minus 4.2 divided by 4.2 into rise in temperature is 100 minus 27. Very easy sum it is. So you solve this. The answer you will get somewhere about, it is very less, that is 3.91, 10 raised to minus 3. And what is the unit of this? It is a resistance upon resistance, and upon delta T we are taking it as temperature, so per degree. So 3.91 into 10 raised to minus 3, you can calculate this. Problem number 8, we are having a 6 meter long wire has diameter, so radius will find 0.5 millimeter. Its resistance is given 50 ohms. Find its resistivity and conductivity. To find resistivity, that is rho, and conductivity. So what is given to you is your length of the wire is 6 meter long and diameter is given to you, that is 0.5 mm. So radius is, from here we can calculate is 0.25. Okay, so millimeter we can convert into meter, 10 raised to minus 3 meter. So diameter divided by 2 is radius, we will get this 10 raised to minus 3 meter we are writing. We are having resistance is 50 ohms, and then you have to calculate what is the resistivity, that is rho of the material, okay, of this material, and second is we are going to calculate its sigma, that is we basically that sigma is 1 upon rho conductivity. So the formula which we are having is R is rho L upon A, or rho is RA by L. We write R, area of cross section of the wire is, we know what is area of the circle is pi r square divided by L. So that is going to give you, which will be rho, which is resistance is R, that is 50, pi is 3.14 or 3.142. Your radius is 0.25 into 10 raised to minus 3 whole square divided by length is, you are having 6 meter. If you are going to find this value entirely, you will get rho is 1.636 into 10 raised to will be minus 6 ohm per meter is the unit. So you will get somewhere about here approximately. You solve, you solve up to 2 decimal also, you can get the correct answer whatever it is. 1.636, calculate this, you will get 1.636 into 10 to the minus 6 ohm per meter. That is, we are having unit for resistivity, okay, because rho is ohm resistivity, it is ohm meter. We are having ohm meter as the unit of this, okay, because rho, so it is ohm meter square upon meter, ohm meter square upon meter, meter and meter will get cut, you will get ohm meter. And then we are having your second thing is we are finding your conductivity sigma. Sigma is the reciprocal of resistivity 1 upon rho, and when you calculate this reciprocal, you can find out in your logbook. If you do, this is my conductivity. If you see the reciprocal of 1 upon 1.636, okay, so you will get nearly somewhere about 6.12. Reciprocal of this 6.12 to 10 raised to 5 will go up, the answer which is given. And here it is ohm meter 1 upon ohm is basically, we can write as mho per meter. So mho per meter will be, you can write this way, mho per meter, or it is sometimes called as Siemens, or 1 upon ohm meter, or Siemens per meter. We can write this as Siemens per meter is the unit of conductivity. Sum number 11th we are doing here, because 9th and 10th color code sums we have already seen in your explanation when we are doing electric current through conductors. We have done already to find the resistance of resistor with the help of color bands, color code. So we are doing directly now. Sum number 11th. Okay. So current 4 amperes. What is given to you is current is 4 ampere. Current flows through an automobile headlight which is emitting light. It is the electrons are emitted. How many electrons flow through the headlight in time? 2 hours. So current is 4 ampere and time is 2 hours. 2 hours means, you know, when we convert it to 60 minutes and into 60 seconds, we calculate in terms of seconds, because SI units is second, so we convert hours into seconds. Okay, in time 2 hours, that is in this was seconds. Okay, so what you are going to find is number of electrons. We are basically finding number of electrons flowing. That is, we write it as n. So what is basically formula we are having? What is current? Current is nothing, it is charge upon time. So charge upon time, and we know that what is charge? Total charge is number of electrons into charge of 1 electron. So I is q upon t, and but we are having, that is, because q is Ne, total charge is number of electrons into charge of 1 electron. So E, we should know the value of E is 1.6 into 10 raised to minus 19 coulomb, charge of 1 electron. So this is number of electrons into charge of 1 electron, so total charge is N. So here we are finding number of electrons actually here, therefore we write N, which is IT upon E, and that becomes your number of electrons, which is current is, we are having 4 ampere current, and time is this much time, that is 2 hours they are telling. So we have to 60 we are doing, divided by charge of 1 electron is 1.6 into 10 raised to minus 19 coulomb. So number of electrons, if you are going to solve this, please solve this number of electrons. Somewhere about 1.8 to 10 raised to 23 is number of electrons flowing through the automobile headlight to us. 12, we are having the heating element connected to a 230 volt draws a current of 5 ampere. Determine the amount of heat dissipated in 1 hour. So how much amount of heat it will dissipated in 1 hour. Heating element, you are having an iron, you are having iron and heating element, you are having a geyser. Okay, so let us solve this where we are knowing one thing, that is because we need the answer. This is in 1 hour. Joules is 4.2 joules per calorie. You can solve this in terms of joules also and in terms of calorie also. Since it is given, joules value is given. So here we are going to find, we are having, what is given to you is the voltage is 230 volts. Okay, and then we are having current is 5 ampere current. And we are having time is, we are having 1 hour, that is 60 minutes into 60 seconds. Always we write down this. What you are going to find is to find your heat dissipated, that is we write delta H. We are going to find work done. Okay, we find work done or heat dissipated is VIT. Okay, so here V is H, energy, here same thing, work. V is 230 into current, we are having 5 into time is 60 into 60 energy. See what answer we will get is 230 into 5 into 60 into 60, we will get somewhere about 414 into 10 raised to, having 10 raised to 8, so 4.14 into 10 raised to 6 we are getting in joules, we are getting the heat dissipated in joules. Now we are going to find in suppose calorie. If you want to find calorie, we are having 1 joule is 4.2, 1 calorie is 4.2 joules. So to convert to calorie, we are going to write H is 4.14 into 10 raised to 6 divided by 4.2. We can find that in calorie. So if you are going to see 4.14 into 10 raised to 6 upon 4.2, we will get approximately 985.8 or 985.7 or 8 you can get. We can write down into, but 10 raised to 3, we are having this 10 raised to 3, we will get in calorie. So we can write in kilocalorie as 985.8. We can write this in kilocalorie.